So here, okay, the double bond between two carbon atoms in ethene, okay, consists of one pi bond and one sigma bond. So which orbital overlap for forming this bond? Yeah. So ethene molecule, this is ethene. Okay, this is the molecule of ethene. So you can see that each carbon, okay, they are forming total of how many bonds. If you count directly in terms of sigma, yeah, this is sigma, sigma, and sigma. Okay, so total 3 bonds. Okay, so if you look over for carbon, carbon is 6. Okay, so if I write down 1s2, 2s2, and then 2p2. Now we know that if I draw this one in terms of like this, 2p2 and then 2s2, what happens here is there is we need to actually have under the excited state. This is the ground state. Okay, you are going to have an excited state which is going to be hybridization will happen. Hybridization is going to be you are preparing for the orbitals for the electrons. So you know that each carbon they need 3 parts for bonding, but you only have 1 and 2 for bonding. They are not ready yet. So what is going to happen? You are going to have this electron over here. This electron, they will actually come over here. Okay, so I erase this part. Okay, so you will have something like this. Okay, this is going to be no longer ground state. This is excited state. So under the excited state, okay, the electrons will be arranged in this way. And then since I need 3, okay, since I need 3, what is going to happen? I'm going to actually hybridize between S and this, okay, because I need 3 only. So this one is called S. This is because of S. And then the P, I only need 1 and 2. So I need sp2. So this one is called sp2 hybridization. So each one, okay, over here, here, and here, they are all sp2 hybridized. sp2 hybridized. This one is also sp2 hybridized, sp2 hybridized. So the bonding that you have over here, the sigma bonding over here, is actually between the sp2 and sp2. Okay, so you can see sp2, sp2, definitely not sp3. sp3 will happen for methane, or sp3 will happen for ethane, okay, because they need 4 bonding. Okay, they need 4. So of course they need 1, 2, 3, 4, sp3. Okay, so this one is going to be sp2, but let's actually look at the pi bonding. The pi bonding happens between this and another carbon's PZ. This is called PZ, and there's another PZ as well. So what happens? These two will join and then will give you the pi bond, which is going to overlap. So the pi bond is caused by, okay, the P, not sp2 or something like that. So it's actually between P and P, and it's always P and P. Do remember this. Pi bonding is always between P and P in your syllabus. So here the answer will be A. Okay, we go to the next question. But before that, do you have any question for this? I hope you learned about hybridization over here. Hybridization is the modification of the orbital so that they are fully prepared to actually form bonding. Okay, so that's a modification. So if you notice like S and P, yeah, because S is going to be like this shape, then P will be this shape. So when they join together, the shape will be like something like this. This is sp hybrid. They have both properties of the sphere and also the dumbbell shape. So that's why we call hybrid orbitals. And then how many sp hybrid orbitals? Like in this case, how many sp2? So you have 1, 2, 3 surrounding the carbon. Okay, so if I want to draw, it will look like something like this. Something like this. Something like this. So the one that will overlap with another carbon will be another sp2. So carbon. Something like this. Okay. So this one is going to be overlap between sp2 and sp2. So what actually overlaps for the pi, yeah? The pi will be something like pz, something like this. And then imagine this one is going to overlap like this. So this is the pi bonding, P and P. Okay, so this one I just erased for you. Okay, anyway, the answer is A. Now for second question, phosphorus, okay, they form a compound with hydrogen called phosphine. This compound can react with H plus. What type of interaction happens between this? This phosphorus is going to be group 15. Okay, so pH3, they have something like this. Okay, the shape, this one is one lone pair and three bonding pair. You should know it's a pyramidal shape. And then you have H plus. So H plus, they don't have electron. They already left. So what happens? This one, this electron, the pair of the electron will be given to the H. So this entire thing, okay, will become plus, okay, because of the H plus over there. Okay, so what type of interaction happens between them? Okay, the interaction that happens between them is dative covalent bond. Okay, not dipole-dipole, not hydrogen bond, not ionic bond. Number 3, okay, the compound has simple molecular structure. Which one is correct? First, I start this by trying to visualize, okay, what is happening. So I put nitrogen. Okay, nitrogen is group 15. So they have 5 valence electron. And then I have CH3. Okay, CH3. So there are 3 CH3. So I just put CH3 over there, CH3 over here, CH3 over here. Okay, so do remember, okay, carbon has 4 valence electrons. So one of the electrons, okay, they will share. Just share over here, they will share. Okay, so it's not complete, but I'm just showing you about nitrogen. Yeah, so nitrogen, they share. And then after that, nitrogen is group 15. So 1, 2, 3, there should be another 2 more electrons for nitrogen. And then there is AlCl3. So Al, and then there's Cl, Cl, Cl. So Al, okay, they have the ability to accept the lone pair of electron. Okay, so it's not showing. So let me check, okay, whether the connection is good enough or not. Can you guys hear me? I think it's laggy. Justin, Lavi, can you hear me? Okay, sorry for just now. Okay, I hope you can hear me now. So again, here, okay, you have this compound. Okay, so what is going to happen is aluminium is able to receive the lone pair from the nitrogen. Okay, so they form dative bonding. So let's actually try to solve this. They say that they attract each other by hydrogen bond. Definitely wrong. Okay, definitely wrong. And then aluminium atom has incomplete valence. Okay, this one wrong spelling, I think, valence. Okay, they have incomplete valence shell of electron. So they told about aluminium, right? So aluminium is 13. So if I write down 1s2, 2s2, 2p6, 3s2, 3p1. Okay, so if I put for 3p1, okay, so 3p1, this is 3p1. They are bonded with 3 chlorine. Okay, I'll just put for chlorine 1, 2, 3. So let's say they actually reacted. Okay, they have 3 chlorine. And then do remember the 2 electrons are coming in. So the 2 electrons will come here and will come here. So you can see aluminium. Okay, earlier they have 3p1. But now, okay, after all this electron is, we put all those electron in, you can see that aluminium don't have any incomplete valence shell of electron. It's complete. Okay, it's complete. So this one will not be the answer. The bonds between aluminium are planar. You see this one, 1 bond, 2 bond, 3 bond, 4 bonds. 4 bonds is already tetrahedral. Tetrahedral is 109.5 degrees. Okay, is a 3D structure. Okay, so they are non-planar. What is planar? It can be linear. Okay, 180 degrees is planar, or trigonal planar is also planar, which is going to be 120 degrees. So it means planar means can be formed on one piece of plane or one piece of paper if you want. Okay, it's actually a single plane. But the moment they have 4 bonds, they are considered to be non-planar. Okay, so that one is also wrong. The molecule contains coordinate, yes, coordinate, and they have covalent bonding, yes, covalent, 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 covalent. Yeah, so that's going to be the answer, D. Okay, the next question. Okay, the diagram shows a molecule that has sigma and pi bond. Anyway, I'm not recording this. Okay, I see. Don't know whether it's actually stopped or what. Okay, never mind. Okay, so we just discuss like normal. Okay, you might not have the video. Okay, now how many sigma bonds are present in this molecule? Okay, so this one you need to be careful, yeah, because sigma bonds, okay, they also consider the hydrogen as having the sigma bond also. So hydrogen, this is sigma. So if I redraw again, yeah, okay, this one hydrogen, hydrogen, hydrogen. So this one will be hydrogen and hydrogen. So if I actually try and put how many sigma bonds, okay, this is 1, 2, okay, one of it will be a sigma bond, okay, so 3, 4, 5, 6, 7, 8, one of it will be a sigma bond, 9, 10, 11, 12, 13, 14, 15, 16, one of it will be a sigma bond, 17, 18. So the answer is going to be C. Okay, I think I show it in a very good manner over here. Okay, first, some of the common mistake is students just count the straight line. They forget about the hydrogen, carbon and hydrogen. That's the problem, yeah. Okay, now, so aluminium, okay, this one they say, okay, this one you remember also, yeah, when it is cooled, okay, when it is at lower temperature, you have Al2Cl6, a dimer. Okay, dimer will be formed when they are lower temperature. This one will be formed when it's going to be higher temperature. Maybe you can check in your textbook, okay? But now they actually ask about what happens to the bond angle. Now, AlCl3, okay, AlCl3 is going to be, aluminum is group 13. So, of course, the bond angle is going to be 120 degrees. But if you have AlCl6, Al2Cl6, they will form something like this, Cl, Cl, Cl. So Al, so if you have Cl, this one will go here, this one will go here, Cl, Cl. Okay, so there is going to be dative bonds here, dative bond here. But what happens surrounding the aluminum? You have total of 1, 2, 3, 4 bondings. Okay, if you have total 4 bondings over there, we can assume it's 4 bonding pair. So that is going to be tetrahedral, which is going to be 109.5 degrees. So what happens to all the bonds over here? All the bonds actually change from 120 to become 109.5. Okay, so they all decrease. All of them. Okay, all of them, the bond will actually change from 120 to become 109.5. Number 6, copper and iodine. Okay, which one of the forces exists, okay, between the neighboring iodine molecule, okay, neighboring iodine molecule, it means I2 and I2, and then particles in solid copper. Particles between solid copper, I think you should know, like atom and atom, metal. So they will actually form metallic bonding. For iodine, okay, they say neighboring iodine, yeah. So it's not between I and I. So definitely it's not covalent bond. It's definitely going to be van der Waals forces. The answer is D. Next question. Now, which pair of elements have chemical bonds? Okay, same type between their atoms in the solid state. So metallic bonding. Phosphorus, okay, phosphorus is non-metal. So of course they don't have metallic bonding, cannot. Chlorine is covalent bonding. Okay, but argon is group 18. So they don't have, they don't bond with another argon molecule. So it's not going to happen. Magnesium is metallic bonding. Silicon, okay, is going to be non-metal, so it's not going to have the same thing. Sulfur is always S8, covalent bonding. Chlorine, Cl2, covalent bonding between them, between Cl and Cl, between sulfur and sulfur. So of course the answer is going to be D. Next question. Two conversions are outlined below. Okay, so NH4 to become NH3, C2H4 becomes C2H6. Maybe NH4, I'll just draw here, NH4. So you have something like this, NH4 to become NH3, C2H4 so you have double bond, and then to become C2H6 don't have double bond. So which similar features? The lone pair of the electron in the product, they have lone pair, don't have lone pair. So might not be the answer. Change in oxidation state of an element. From here nitrogen to here, okay, and then carbon to here, there is no change, okay, of the oxidation number here. So might not be correct. Disappearance of pi bond, okay, yes, disappearance, but this one there's no pi bond, suddenly what to disappear, so no. Decrease in bond angle, okay, so if you look at the bond angle, so this one is 4, so it's supposed to be 109.5. Now this one is pyramidal, okay, pyramidal, so it's going to be 107, okay, so there is a decrease. If you look over here, there is 1, 2, 3, so 120 degrees, okay, and now 1, 2, 3, 4, so 109.5, okay. So here also there is a decrease. So the answer is going to be decrease in bond angle. Now number 9, okay, please be very careful with number 9 because we students tend to actually just simply take the answer. Okay, they say nitrogen, okay, 1, 2, 3, 1, 2, 3, okay, cannot 1 2 3 90 cannot, okay, cannot, okay, then they take, oh, 1 2 3, okay, 120, then they select the answer as C. But okay, some students might get surprised, this one is actually not C, it's D. Why? Okay, you need to actually look at nitrogen. Nitrogen is 15, okay, so 285, okay, so they have 5 valence electron. So one for bonding here, one for bonding here, another one for bonding here. So they do have another 2 for bonding there. Okay, so it means there is another 2 lone pair, 1 lone pair over there. Okay, so that 1 lone pair of electrons, they will actually push the bond angle so that you will look like something like ammonia. Okay, like they have a lone pair, they push. So they will become 107 degrees. Okay, so the nitrogen, okay, so 1s2, 2s2, 2p6, 3s2, 3p3. Okay, so 3p3, 1, 2, 3, but do remember these 3s2, they will exist here. Okay, so this one is the lone pair. So the answer is D. So number 10, okay, number 10, Shane, what is the answer? Have you done number 10?
Haven't.
Aneta, have you done number 10?
Not that, sir.
Haven't. Okay, I'll just go very fast with you. BF3, yeah, boron is going to be group 3, okay, 13. So BF3 is definitely going to be trigonal planar. Okay, and then BH4 is negative, and A, yeah, and A is positive. So boron is 3. Okay, so they will join with 3 hydrogen first, 1, 2, 3, and then okay, what happens to another H here, H minus, yeah, so they have electrons, okay, and then they join over here. Okay, they give the electron pair to boron, so boron is accepting those electron pair. So what happens total, you have 1 2 3 4 bonding pair. So if you have 4 bonding pair, that's automatically going to be tetrahedral. Now, I think Jody and Charlton was discussing about what is square planar. Now, square planar is supposed to be something like this. They have 4 bonding pair and then 2 lone pair. That is called square planar. It's a modification of octahedral. Octahedral is going to be octahedral. They have 6 bonding pair. Then it's octahedral. But this one is going to be square planar. If you still not sure, okay, please refer to the video that I